Alright, Common Core Algebra 1, here we go for our last section in this unit. So this will be the last video. 2.5 is all about absolute value equations and inequalities. So by the end of the lesson, we'll be solving equations, absolute value equations and inequalities, and then also graphing their solutions. So first thing that we need to remind ourselves is what an absolute value is, and that is referring to the distance from 0 on a number line. So it's always, because we're talking about distance, you want to make a note, it's always positive. Okay, so -6, the absolute value of -6 is going to be 6. Likewise, the absolute value of 6 is 6. And the reason for that, if we think about drawing a number line, if I put 0 in the middle here, both 6 and -6 have a distance or a length between them of 6. So anytime we have an absolute value, there are two numbers that could get that value. If we think of -7, that would be +7, and +8 stays +8. So either number, whether it's positive or negative, will give you a positive absolute value. It's always going to refer to the distance, and so therefore always be positive. Now, to solve an absolute value equation, or what an absolute value equation is when we have a variable inside an absolute value. Okay, an example would be something like this. So you see our variable x is inside our two vertical lines here, and these are the ones that we call the absolute value. So I would read this: the absolute value of 2x plus 6 minus 8 equals 15. And in order to solve that, we're going to start by isolating the absolute value, and then we're going to create two equations, and we're going to create one where it's a positive value and one where it's a negative value. So that's going to give us two equations, and then we solve the equations, and we should get two solutions. You may get the same solution twice, but most times you're going to get two different solutions. Okay, and you need to make your positive and negative equations before you solve either equation. So an example to look at that, we're going to start by isolating our absolute value, and to do that, we want this piece to be alone, which means we need to get rid of this -8. So I'm going to add 8 to both sides, and that will end up with the absolute value of 2x plus 6 equals 23. And that works so far. The next step then to remember is create two equations, one positive, one negative. So what that means, we're going to drop our absolute value. If we make the positive one, we just leave it as 2x plus 6 equals 23. You see that 23 stayed positive. If we make the negative one, we start the same way, 2x plus 6, but now we're going to say equals -23. And the reason for that is because the absolute value of -23 is still positive 23. So that tells us that this 23 could come from a positive or negative 23. And then to finish off the problem, we are just going to solve both equations. So we should get two solutions. So I'm going to rewrite that first one we created. 2x plus 6 equals 23. I subtract 6 from both sides. So I have 2x equals 17. And then I divide both sides by 2. So x is equal to 8.5. Okay, that'd be one solution, but remember we need two. So I rewrite my other equation still. 2x plus 6 equals -23. I subtract 6 from both sides, and I get that 2x equals -29. The last step, divide by 2 so that we isolate the x. And so x is going to be a negative, what do we get here, 14.5. And that would be our second value. So you notice they're not even really related. The only reason they're related is because we have a positive and a negative 23. You need to remember to separate them into positive and negative 23s, then solve each equation independently. Okay, so after we talked about an absolute value equation, we've also talked about inequalities this chapter. So an absolute values inequality is the same idea, it's just that now we have an inequality with a variable inside the absolute value. And when we solve this, in order to drop our absolute values and have a positive and negative, it's going to create a compound inequality, which remember came from section 2.4. So you may need to review 2.4. Now, to decide whether it is an and inequality or an or inequality, we're going to look at something like this. The big thing to notice here is that when it's less than or less than or equal to, it becomes an and inequality. An example of that would be 3x plus 6 is less than negative 15. So to become an and inequality, remember, we're going to have 3x plus 6 is less than, that should be positive 15, sorry, this is a positive 15, is less than 15, and also the and part now comes, remember we need to say it's greater than a negative 15. So this is an and compound inequality. If you're not sure why this is an and compound inequality, make sure you go back and review your 2.4 notes, or even better, watch the 2.4 video again. Okay, the other option then is if it is greater than or equal to, and this should actually say it becomes an or inequality. Okay, an example of that would be very similar, where we actually want to change this symbol now. Instead of being less than, we're going to say greater than or equal to. And so that would become two inequalities. One where 3x plus 6 is greater than or equal to 15, or one where 3x plus 6 is less than or equal to a negative 15. In other words, it can't be both of these things at once, so we make it an or. And this first one, it can be both of these things at once, so we say and. Okay, solving those equations then, we are going to start the same way. We're going to isolate the absolute value. So in my example here, I'm going to add 7 to both sides. So I end up with the absolute value of 3x minus 6 is less than or equal to 12. Next step, we're going to create the appropriate compound inequality. And looking at the previous slide, remember we have less than or equal to. So in this equation, you see we have less than or equal to, which tells us that is an and inequality. That tells us to do and. So we're going to say 3x minus 6 is greater than or equal to negative 12, and is also less than or equal to 12. Okay, the whole reason we're doing an and is because of this symbol right here. And then finally we're going to solve the compound inequality, making sure that we have all solutions found. So negative 12 is less than or equal to 3x minus 6 is less than or equal to positive 12. Remember, when solving an and compound inequality, we don't do things just two sides, because technically there are like three sides here. So we end up with negative 6 is less than or equal to 3x is less than or equal to 18. And then we finish solving by dividing both sides by 3, so that's going to be less than or equal to 6, and also greater than or equal to negative 2. Okay, this would be our compound inequality. And finally, how to graph that. So I have the same example here. I'm going to mark the middle of my number line that I already created here as a 0. Let's say we count by 2, so I go all the way to 6, and negative 2, negative 4, negative 6. We include, so remember that tells a closed circle at negative 2. We include 6, so a closed circle at 6. And because it's an and statement, we shade everything in between. Again, if you're confused about how we did this, because I went over it pretty quick, review your 2.4 notes and or watch the 2.4 video again. This is just essentially from that. Alright, so that is it for this lesson. Next time we get in class, or maybe the time after, depending on how much progress we can make, we will be practicing creating some absolute value equations and inequalities, which is going to generate some higher order thinking, and then we will graph those solutions. Alright, we'll see you next session.